Okay, so let's go through concentration of solutions. This is the last little bit of our chapter 14, 14.3 and 14.4. And then we will move on from there. So this is the last little bit before we actually finish area of study 1 for our unit 2. So let's get going. So as we mentioned the other day, when we compare concentration, if the sample is coloured, we get an indication of how concentrated something is from its depth of colour. Okay, so if we were to have 2 glasses of cordial which have equal concentration, they would taste the same, but we can have different volumes. Okay, so in this example here, we can say that the concentrations are equal. Okay, so they have the same ratio of solute to solvent, but the volumes are different. Okay, so this would be like making up a full jug of cordial. Okay, so a full jug of cordial, so maybe 2 liters, and then pouring out a single glass from that jug. The 2 solutions would have exactly the same concentration. We haven't added or changed anything to them. We have just separated the 2 volumes out. So the concentrations would be the same. So the dispersion of the solute through the solution is going to be the same in both. Okay, remembering that solutions don't settle, they stay homogeneous throughout. Okay, if we look at these 2 here where we can see there's a difference in concentration, okay, what we can see with these ones, we have a darker color in one than the other. These 2 hold the same volume. Okay, so they have the same volume of solution, but different concentrations. Okay, so it is important when we're looking at these for us to be able to work out what's going to be the same and what's going to be different in each one that we're looking at. Because if we have a different concentration, then we have a different amount of substance, okay, in each one. Okay, so the concentration will be different. If I have a different amount in the same volume, my concentration is going to be different, because concentration is simply a measure of the amount of solute in a given volume. Okay, we're always looking at the amount of solute in a given volume. So there is some terminology that we need to learn. Of course, concentrated and dilute. A concentrated solution has less space between particles. There is a higher ratio of solute to solvent. Okay, whereas a dilute solution will have a much lower ratio of solute to solvent. Okay, so there is less substance per volume in the case of a dilute solution. So if we want to make a solution more concentrated, we can add more solute and it will become steadily more concentrated up until a saturated solution, remembering that a saturated solution can't hold any more. When our liquid is diluted, we can add more solvent. So this increases the space between the particles, but the number of moles of substance doesn't change. Okay, so when we're diluting, we add solvent rather than solute, and it makes the concentration lower. So there are many different ways to express concentration depending on what we're doing. If we're looking at water quality or air quality, then the concentration units need to be very low because we're looking for very small amounts of substance. If we're wanting to do reactions, then we're going to usually be using molar concentrations. And then if we're using them in general society, say buying hair bleach or things like that, we use different concentrations as well. So it depends on the context as to the solutions that we actually use. Of course, in our study of chemistry, we will use certain concentrations more often. So this is a table of the units of concentration. Okay, it has lost its formatting here. This should be 10 to the 6. Okay, so this is parts per million is 1 part in every million parts. So the other way to write this is you will have parts per million if you have milligrams per liter. So if I said I had 5 milligrams per 1 liter of solution, okay, so a total volume of 1 liter, what I would have is a 5 ppm solution, a concentration of 5 ppm. There's a question in your textbook on page 351, which says to give the concentration of the following solutions in parts per million, and it gives us a concentration of calcium chloride that is 25 milligrams per 5 kilograms of solution. Okay, so remembering that 1 milliliter is equal to 1 gram, or close enough to, this means that I have 25 milligrams per 5 liters, or 5,000 milliliters. Okay, so if I want to get that into parts per million, we're going to use the unitary method. Okay, so that's 25 milligrams per 5 liters. That means I'm going to have 5 milligrams per liter. Okay, if I divide both by 5, we're creating an equivalent ratio. Okay, 5 milligrams per liter is going to equal 5 ppm. So if we can get it to milligrams per liter, then that what is on the numerator becomes my ppm measurement. The other concentration units that we can have are, of course, percentage weight for weight. So this would be grams of solute per 100 grams of solution. Percentage volume per volume is milliliters of solute per milliliters of solution. Okay, so pay attention to the units here. These ones are per 100. Okay, so the percentages are always per 100, and it's grams, and the volumes are always given in milliliters, which is different to most other things that we deal with in chemistry, where we're often dealing with liters. So then, of course, percentage weight per volume is grams of solute per 100 milliliters of solution. And these ones are of solution. So this is the final solution. Okay, so this is 5 milliliters per 100 milliliters of final solution. And then molarity, which is one of the most common ones that we're going to use, is of course moles per liter. So we do need to use moles again in this situation. So these are the questions that you were set last week in class. Remember that you need to be correcting your questions as you go. Okay, otherwise you don't know if you're getting them right or wrong. There are also work solutions available on the online version. If you need access to these, of course, let me know. So these are a revision of how we convert between units. Okay, so one of the things that you're going to have to do is become comfortable with converting between different units of volume so that we can then convert between different units of concentration. Okay, so just a revision that if we want to go from milliliters to liters, where we're going from a smaller volume to a larger volume, we're going to divide by 10 to the 3, which is the same as dividing by 1,000. If we want to go from liters to milliliters, we're going to multiply by 1,000. Of course, liters to kiloliters is going to be exactly the same. These are metric conversions, so we will divide by 1,000 going that way, or multiply by 1,000 coming back. Okay, milliliters, again, the same difference, 10 to the 3 difference between a microliter and a milliliter. So if I want to go from milliliters to microliters, I will multiply by 1,000, okay, and then of course divide by 1,000 going this way. So in this way, we can also see that microliters per liter is going to be the same difference as milliliters to kiloliter, okay, or milligrams to liters when we have a look at our parts per million and parts per billion. So you can, if you are comfortable using your index notation, what you're looking for is 1 is to 10 to the 6 ratio when we're talking about parts per million. However, remembering we can also, if we can get it to milligrams per liter, we are equal to parts per million. So the common concentrations that we use are mass per litre of solution and moles per litre of solution. Okay, so you need to be able to be comfortable primarily converting between milliliters and litres is the most common ones that you're going to have to convert between, and into ppm. ppm comes up a lot. So moles per litre is going to require us to do revision of the mole. I'm going to stop this here and start a new video where we will review the mole and start looking at moles per litre calculations.